Hey everybody and welcome back to Coding with Edric. In today's episode, this will be a continuation of our variables episode actually, and it's entitled Overflow. Now right here I am opened up dev C++, and as you can see here I've actually created a code, a program that is actually in C++. It should be in C. So I'll just copy, paste, and save. Place it to C source files and then do overflow underscore demo1. Okay. It's now a C file. Should have done that earlier. But if we, as you can see here, we have a single variable x that is 21474833647. Now, why is this a special number? You would ask. This is actually a very special number, and you will see later. Now, in the printf, we see here that it's a %d, so meaning we're looking at x. Right here, we're trying to format it using x, just like in our last episode. And here we also have another %d, which has x plus 1. Here in the printf, you could also format mathematical operations here, and it will return the value. It will print out the value. Now, what do you think will be the output of this code? Type your answers in the comments below. Okay, you have your answers now? So, for all you programming veterans there, you would actually know the answer already, or if you coded this yourself, you would know the answer already. So don't try to cheat on that. Also, don't ask Mr. Google. So let's try to compile and run this. Myself, I already know what the output is going to be, but I want you to see it for yourself as well. Let's compile and run. Okay, it's compiling. As you see here, we have 21474833647 and negative 21474833648. Now, why does this happen? It's because of a phenomenon in any programming language except for Python for some reason called overflow. See, in overflow, there are limits to data type. For example, the integer, the limit are these two numbers. The lowest possible number that an integer could have is negative 21474833648, and the highest possible number that an integer could have is 21474833647. Now, how do we get by this? There are two ways. Okay? The first way is by creating an unsigned int. Let's call that y. Let's place it equal to x plus 1. But of course, let's do some printfs. Instead of %d, since this is an unsigned int, we place in %u. And we do a \n, then we parse in y. We place in y. So printf %u y, so meaning we have an unsigned int, and that unsigned int is y. It's unsigned integer because there are no negative numbers in this. So that means it's the same amount of space that the variable is taking up, but it just doesn't have negative numbers. So if we compile and run this, we would be able to see the positive 21474833648. Now, the second way is by creating a long int. Let's call that z, and let's equal it to x plus 1. And then let's print it. So printf, and again, instead of %d, we're going to be placing %ll, because that's long int. Then output z, Now, if we compile and run this, we would also end up with, did I mess something up? I think it's LLD instead of just LL. There you go. But why is it negative? We see it as negative because it is still thinking that we're adding two regular integers. So, what we have to do here is we need to cast it. Now, I didn't explain this in the last episode, in the previous episode, because I kind of ran out of time in the previous episode. But for you to cast, a variable, you place parentheses before the value or before the variable after the assignment operator. And we know that the assignment operator is the equal sign. So let's place there long int x. We just need only one. We only need one to be cast. So if we try to do it, there we go. 214-748-3648. So those are two ways how you would be able to overcome this overflow. However, there are still limits to the unsigned int and the long int. How we are going to know that for ourselves, let's say for example, I want to include another header file so that we could see for ourselves. This header file is called limits.h. It's a built-in header file when you download dev C++, and I will when you download C, actually, not just in C++, not just in dev C++, I will leave a link in the description where you could find more information on limits.h. But let's say for example, let's find the limits, the actual limits to the int, now here, as you can see, I have two placeholders here, %d and %d. Now I cannot just place in one value, I need to place in two values. So for example, here I want int min and int max, so that we would be able to find the limits to the integer. So if we compile and run this, we would be able to see the two limits of the integer data type, which are negative 214-748-3648 and 214-748-3647. Now we could do this for all the other data types that we have. So let's say %u, and we place in uint min, which is unsigned int, and uint max, which is unsigned int as well. Then we have uint min is undeclared. Well, let's not do uint min. Let's do I don't actually remember the unsigned int, but I do remember the long, it's L long, the long. I think it is this. Yes. Now, as you can see, the L long, or the long int, it is super big. It's like, how much is this? This is thousands, million, billion, trillion, quadrillion, quintillion, 9 quintillion. From negative 9 quintillion to 9 quintillion. That's a very big number. However, there are still limitations. Okay, so I'll be leaving a link to the limits.h in the description. And when you cast, another thing in casting, when you cast, you could also cast values. So for example, if I want to cast 1 instead of X, I can. And it will give me the same output. Give me the same output. You could also place in here the unsigned int. It will stay the same, hopefully. Yep, it will stay the same. And you could even place this into a float, into any other data type you want. You can even place this as a character if you want to, although I don't advise you do. But there you go. That is the end of today's episode. I hope you enjoyed it. Leave a like, comment, and subscribe if you like the video. And tell me in the comments below, have you learned anything new? With that, I hope to see you in next episode of Coding with Edric. Take care.